Hello, Econ 160. Professor Kung here, coming to you with our very first online video lecture. This lecture is coming to you at a time of global coronavirus pandemic. So I hope that wherever you are watching from, that you are staying safe, staying healthy, and practicing good hygiene. Today's lecture is on the topic of the costs of production. Today's motivating observation is that if you look throughout history, what you'll see is that a lot of times major changes to the way societies are organized are driven by reductions in the cost of production, either through improved production technology or improved production methodology. You can think of Eli Whitney's cotton gin, which mechanized agriculture, or Henry Ford's assembly line, which allowed for mass production. So of course this leads us to a couple of questions. First, why do reductions in production costs often lead to such drastic and important changes for society? And second, what are the costs of production? What kinds of costs are there? And how do we calculate them? So let me start by explaining why economists think production costs are so important. And we're going to think about that by considering the effect that the assembly line had on the market for automobiles. So what did the assembly line do? Well, before the assembly line, marginal cost for producing automobiles was very high, and after the assembly line, marginal cost became a lot lower. So what did this do to the market for automobiles? We can answer that by using comparative statics. So let's draw a supply and a demand diagram. And we're going to start by drawing the supply and demand diagram from the time period before the assembly line was invented. So here is a demand curve. And where do we draw the supply curve? Well, remember, we can think of the supply curve as the industry marginal cost curve. So before the assembly line, marginal costs were very high. So the supply curve should be something like this, way up here. So this would be marginal cost before the assembly line. Okay? Now, what did the invention of the assembly line do to the market? Well, it reduced the marginal cost for producing automobiles drastically. And what that means is marginal cost is going to exhibit a downward shift. And so this red line is our marginal cost curve after invention of the assembly line. Okay? And what did that do to the equilibrium? Well, if you look at the equilibrium before the assembly line, it's up here and it has a high price and a low quantity. And if you look at the equilibrium after invention of the assembly line, which is over here, it has a much lower price and a much higher quantity. So what did the assembly line do to the market for automobiles? Well, now not only could people buy cars at a cheaper price, but they're able to buy a lot more of them too. So the car might have gone from something that only rich people could afford to something that everyone can have. And that's the kind of shift that can have a really big impact on society. In fact, most economists believe that the main driver for economic growth over the long run is indeed improvements to technology which drive down production costs. And economists call this productivity gains. And so the goal of most innovation policy and a lot of economic policy is to make sure that our markets are providing the right environments to foster an appropriate amount of innovation and entrepreneurship that will drive long-run economic growth through productivity gains. So hopefully you're now convinced that it's important from a long-run economic growth perspective to think about production costs. But it's also important to think about production costs from a smaller picture perspective, because costs are also something that companies have to think about day in and day out. So what are some of the types of costs that firms incur? Now, if there's anything that I want you to take away from this course as a whole, I think these next two slides are certainly going to be among the very top, because they're going to be practical for you regardless of which kind of business you go into. Because the types of costs that I'm going to list are going to be exhaustive, meaning they pretty much cover all the kinds of costs that a firm could face. And all firms have to face each of these costs in some degree or another. All right. So the first type of cost that we're going to talk about is labor costs. And that's the cost that a firm pays in order to hire its workers. So for example, the wages that a coffee shop pays to its baristas would be considered a labor cost. But it's not limited to the physical labor of people doing the grunt work for the company. It could also include the salaries that the company pays to its accountants, to its managers or its engineers, or even its CEOs would count as labor costs as well. Now, the second type of cost is what we call capital costs. The capital costs are costs that a firm pays in order to buy or rent the fixed assets that it uses in its production. And so fixed assets are things that are durable and can be used repeatedly. So for example, machinery and equipment like an espresso machine that a coffee shop might use would count as a fixed asset, and thus the cost that the coffee shop spends to buy it or rent it would be considered a capital cost. Another example might be the cost of buying a computer for your employees. That would be considered a capital cost as well. One major important capital cost is the cost of buying or renting the land that your company sits on and the office space that your company uses. Okay. Something that's important to note is that if a firm borrowed money in order to pay for its capital, for example, if a newly started coffee shop borrowed its initial money that it used to buy its espresso machines and its coffee roasters, then the interest payment on those loans would be considered a capital cost. And so for this reason, you're often going to hear of the interest payments that a company pays on its loans. People sometimes call them capital costs. Okay, so besides labor and capital costs, there are three other types of costs that represent things that a firm might pay money out for. Okay, and I've lumped them together in the same bullet point, even though they really represent three different categories of costs. Okay, and so the first is materials costs. Materials costs are the costs that a firm pays in order to buy the materials that are used up in the production process. So for example, coffee beans are a material cost for the coffee shop, and the coffee beans are something that gets used up in the creation of the coffee drinks. Another example might be steel, aluminum, and rubber for a car manufacturer. These are physical inputs that are used up in the production of a car. Okay, so the second of these three is energy costs. This is very simple. It takes energy to run a company, typically electricity, but it could include other forms of energy such as natural gas as well. But anyway, the costs that a firm pays for the energy it uses to run its operations are called energy costs. Okay, and then finally there's something called purchase service cost. So a purchase service is a service that a company basically purchases from another company rather than producing it in-house. So for example, a coffee shop might decide that it wants to run an advertising campaign, but it doesn't have any in-house expertise for doing that. So it might hire a marketing firm to run the advertising campaign for them. So costs that a firm spends in order to purchase services from other companies are called purchase service costs. All right, so labor, capital, materials, energy, and purchase services. These costs are an exhaustive list of the types of financial costs that a firm might have to pay. But there is one other cost that doesn't represent a monetary cost, but is every bit as important in terms of determining how a firm behaves and what a firm decides to do, and that's opportunity cost. Right, so we learned about opportunity cost in our very first lecture. From the perspective of a firm, opportunity cost is simply the value of the time and money that a business owner could have spent doing other things other than running the business, right? So it could be uh, the best job that the business owner could get if they decided not to run the business, or it could be the value of the leisure time if that particular owner would prefer to spend their time in leisure if they weren't running the business. Okay. Unlike the labor, capital, materials, energy, and purchase service cost, opportunity cost does not represent an actual flow of money or payments out of the firm. Okay, but like I said, it's every bit as important in terms of the firm's calculations of what to do and its strategy. All right, so let's do an example on thinking through the different types of costs that a firm might have to pay. So this is Mandy's coffee shop. Mandy owns a coffee shop. Every year she pays $100,000 in salary and benefits to hire 2 baristas. She pays $80,000 a year on her rent and on the interest payments on the loans that she used to purchase her equipment initially. And finally, her annual materials and energy costs are $20,000 a year. And we're going to assume that she doesn't have any purchase service costs. Okay, and the coffee shop generates $250,000 in revenue each year. Question 1. What is Mandy's coffee shop's annual cost of labor? Okay, that's very simple. She pays $100,000 in compensation, including both salary and benefits, to her workers, and so her labor costs are $100,000. What is Mandy's coffee shop's annual cost of capital? Well, she's paying $80,000 in total on both rent and interest payments on the equipment that she purchased. So that will be $80,000 a year on capital costs. And what is Mandy's coffee shop's annual cost on materials and energy? It says right there, $20,000. Okay, and so her total financial costs, including labor, capital, material, and energy, adds up to $200,000. Okay, and she's making $250,000 in revenue each year. So what is her profit every year? It is $50,000. Okay? All right, so now let's think about adding opportunity costs to the mix. So this is the exact same example, except this time we're adding some more information. It says here, if Mandy was not running the coffee shop, then she'd work as an accountant for $70,000 a year. Okay, so it's telling us what Mandy would do other than running the coffee shop. Okay, so what does that mean about opportunity cost? What's Mandy's opportunity cost for owning the coffee shop? Well, it says right here, if she weren't running the coffee shop, then she'd work as an accountant, right? So her opportunity cost is $70,000 a year. So based on this, should Mandy stay in business? Well, from the previous slide, we saw that Mandy's profits per year are $50,000. And here we're saying that she could have been making $70,000 as an accountant instead. So should Mandy keep running her coffee shop? Without any further information, the answer would be no, right? She'd make more money working as an accountant rather than running this coffee shop. Okay? But what if her love of coffee was actually worth something to her? So let's say it was worth $30,000 a year to Mandy to own the cafe. In that case, the opportunity cost actually drops down to $40,000, right? because the cost of not working as an accountant is offset by the love of coffee, which is worth $30,000. Right? So in that case, if the new opportunity cost, if she has a love of coffee, is $40,000, and the profits that the coffee shop is generating is $50,000, then now the answer would be she should stay open, right? Then she should keep running the coffee shop. All right. All right, so Mandy's decision making in the previous example shows us that when businesses decide to either shut down or stay in business, it depends on more than just the profitability of the firm in terms of pure financial profit, right? Profitable businesses might still decide to shut down, and unprofitable businesses might still decide to stay open. And what it really depends on is the owner's opportunity costs. And so therefore, economists have to distinguish between what's called accounting profits and accounting costs and economic profits and economic costs. All right? One isn't better than the other. They're just meant to measure different things. Okay? So accounting profit and accounting cost is simply meant to measure the flow of money into and out of a firm. So accounting costs are simply all the costs that are flowing out of the firm for things like labor, capital, material, energy, and purchase services. But accounting cost does not include opportunity cost, right? Because opportunity cost is not an actual flow of money out of the firm. Okay, and then accounting profit is simply the money flowing in, which is revenue, minus the money flowing out, which is cost. Okay, so that's accounting profit and accounting cost. Okay, so in contrast to accounting cost and accounting profit, which simply tries to measure the money coming into and flowing out of a firm, economic costs and economic profits are how firms actually make decisions, all right? And so economic cost includes accounting costs, but in addition to the accounting cost, economic cost also includes the opportunity cost. So it includes the cost of what the business owner is losing by choosing to run the business instead of doing something else, okay? And then economic profit is simply whatever revenue the firm is making minus the economic cost rather than the accounting cost. Okay, and so the reason why it's important for economists to think about economic costs rather than accounting costs is because businesses are going to make decisions to maximize their economic profits, okay, not just their accounting profits, right? As we saw, some businesses that are actually making positive accounting profits, so they might be making good money, might nevertheless decide to go out of business if the economic profits are not positive, right? If they're not making positive economic profits. They might still go out of business even though they're making positive accounting profits. And vice versa. A business which is making negative accounting profits, right? So they could be losing money in terms of profitability, but if the business owner just loves what he's doing so much, then he might still choose to stay in business, okay? So economic profit in that case would be positive even if accounting profit is negative. All right, so let's apply our definitions of accounting cost and accounting profit and economic cost and economic profit to our Mandy's coffee shop example. So it's the same example as before, the same numbers. Question 1, what is Mandy's accounting cost and accounting profit from running the coffee shop? We already did this. We saw that the accounting cost was $200,000, right? The $100,000 labor, $80,000 capital, and $20,000 on materials and energy. And the revenue was $250,000. And so the accounting profit was $50,000. Right? Okay, so question 2, what is Mandy's economic cost and economic profit from running the coffee shop? And we're just going to assume that there is no special love for coffee for this particular example, okay? And so the revenue is still 250,000, right? The accounting cost is 200,000. Yeah. Uh, and the only thing we have to add in now is the opportunity cost, right? And so Mandy's opportunity cost is 70,000, right? Which means her economic cost is equal to the accounting cost plus the opportunity cost. So the economic cost is actually 270,000, okay? And the economic profit is therefore 250,000 minus 270,000, so minus 20,000. All right. So in this example, since economic profit is negative, Mandy would decide to shut down the business. All right, now that we've spent some time talking about the different kinds of costs a firm could face, as well as discussing the differences between accounting and economic cost, let's switch gears a little bit now and think about how firms can calculate their costs. To do that, we're going to start with something known as a production function. A production function is simply a mapping from different combinations of inputs into units of output. So a production function is going to basically say, okay, for each combination of inputs that I use, how many outputs can I make? So the example that we have here on the slide is Mandy's production function. So her two possible inputs are baristas and espresso machines. And so her possible choices of the number of baristas to hire is here on the rows. Okay, so she can go from 0 to 8 baristas. And the possible number of espresso machines that she could have is shown here on the columns. All right, and so the way you want to read this table is that if Mandy were to hire 3 baristas and purchase 2 espresso machines, then she would be able to make 30 espressos per hour. Or I should say her coffee shop would be able to produce 30 espressos per hour. If she wants to increase the number of espressos per hour that she can serve, let's say if she increases her number of baristas to 6 and her espresso machines to 4, right, then she can actually make 60 espressos per hour, okay? So that's all. That's very simple. A production function just shows for each combination of inputs how many outputs the firm could possibly make. Okay, so one feature of many production functions is something known as diminishing marginal product. Now, if you look at our production function in the table on the left, you'll notice actually that as you increase the number of baristas without increasing the number of espresso machines, the amount of espresso that you can make actually starts to not change, right? So if you have one espresso machine, um, as you hire the first barista, you can make 10 additional espressos per hour. When you hire the second barista, you can make another 10 espressos per hour. But then when you hire the third barista, you only make 5 more. When you hire the fourth barista, you make another 5 more. But then actually when you hire the fifth barista, you don't actually make any more espressos, right? And so maybe the reason for that is the espresso machine is already being used at capacity, and adding more baristas doesn't actually increase your productivity any further, right? And similarly, if you had 3 espresso machines, right, then you can hire up to 6 baristas before the marginal product for each additional, the marginal product for each additional barista hired starts to decrease, right? Okay, and similarly, if you fix the number of baristas, so if you only have 1 barista, then regardless of the number of espresso machines, you're going to be making 10 espressos per hour only, right? If you have 2 baristas, you're only going to be making 20 espressos per hour, right? Let's look at if you hire 6 baristas, then the first espresso machine gives you 30 additional espressos per hour. The second espresso machine will increase that from 30 to 50 for an additional increase of 20. The third machine gives you an additional increase of 10. And the fourth machine isn't helpful when you only have 6 baristas, okay? And so this idea that your output starts to slow down as you increase one input without increasing another input is what's known as diminishing marginal product, okay? And typically, diminishing marginal product happens because in order to produce your product, you need a combination of different inputs, and the inputs aren't perfectly substitutable, right? So you have to increase all of the inputs simultaneously in order for you to increase your total amount of output in the most efficient way possible. So that was the production function. Now we're going to talk about how we can go from production function to actual costs, right? So the production function tells us for any combination of inputs how many units of output we can make. If we then have data on the cost of each of those inputs, then for any amount of output that we want to make, we can figure out what the cheapest cost is to produce that amount of output, right? So we can ask a question like, let's say Mandy wants to make 30 espressos per hour. What's the cheapest cost for her to make 30 espressos per hour in terms of how many baristas to hire and how many espresso machines to rent, okay? So let's do an example. Suppose the wage of baristas is $15 per hour and the cost to rent an espresso machine is $10 an hour. All right, and we're going to go down this table on the right and calculate Mandy's cost function. We're basically going to ask for each amount of output that Mandy might want to make, what is the cheapest cost in order to make that? All right, so let's start with 0 espressos per hour. Well, what's the cheapest way to make 0 espressos per hour? Well, clearly it's to hire 0 baristas and 0 espresso machines, right? And then so the cost per hour is simply going to be 0, right? Okay, so that was really trivial. But now let's ask, what's the cheapest cost for Mandy to make 10 espressos per hour? And so the way we can do this is we can look at the production function and ask ourselves, what's the cheapest combination of inputs that makes 10 espressos per hour? And these are all the combinations of inputs that can make 10 espressos per hour. And so what's the cheapest? Well, it's to hire 1 barista and rent 1 espresso machine, right? And since baristas are $15 an hour and espresso machines are $10 an hour, the total cost to make 10 espressos per hour is going to be $25 an hour, okay? Now let's ask, how can we make 20 espressos per hour? These are all the possible ways to make 20 espressos per hour. What's the cheapest? It's going to be to hire 2 baristas and have 1 espresso machine. Okay, and the cost here is going to be $30 for the baristas and $10 for the espresso machine, and so $40 an hour. Okay, now let's do 30. In order to make 30 espressos per hour, these are all the ways in which we can make 30 espressos per hour, right? And what turns out to be the cheapest way? Well, espresso machines are cheaper than hiring baristas, and so the cheapest way is actually to have 3 baristas and 2 espresso machines. And so the cost for that would be $45 for the 3 baristas, and then $20 for the 2 espresso machines, right? And so that would be $65 an hour, okay? All right, I think you get the picture, but let's just do a couple more. So how do we make 40 espressos per hour? These are all the ways to make 40. The cheapest is clearly going to be here, 4 baristas and 2 espresso machines. To hire 4 baristas, that's 4 times 15, so it's 60. And then 2 espresso machines, 20. All right, so it takes us $80 per hour to make 40 espressos per hour. Okay? All right. Yeah, let's just do one more. So 50. How do we make 50 espressos per hour? These are the different combinations of inputs that give us 50. All right, again, espresso machines are cheaper to hire than baristas. And so the cheapest way for us to make 50 espressos per hour is to hire 5 baristas and rent 3 espresso machines. All right, so 5 baristas would be $75 per hour, and 3 espresso machines would be $30 per hour, and so that would be $105, right? Okay, and so you can figure out 60, 70, and 80 on your own. All right, so hopefully you get the picture. In order to calculate a firm's cost to produce any particular amount of output, we simply look at the production table and we look at how much it costs to employ those inputs that are required to produce that amount of output at the cheapest cost. Okay, so that was how we go from a production function to a cost function. And as a reminder, the cost function is the mapping from the amount of outputs that you want to make to the cheapest cost it would take to make that amount of output. All right. And for the most part, we are going to be working directly with cost functions. Okay. And at this point, I want to describe 2 different types of costs, variable costs and fixed costs. A variable cost is a cost that changes when you change the amount of production. And so variable costs are usually going to include most labor costs, almost all material costs, and most energy costs, as well as some capital costs. So going back to our coffee shop example, the variable costs for a coffee shop are going to be the number of baristas it employs. As it wants to serve more drinks, it's going to need to employ more baristas. Maybe the number of espresso machines that it has. Definitely the amount of coffee beans that it purchases and the amount of electricity that it uses up. Okay. So again, variable costs are costs that increase as you want to increase the amount of production. In contrast, fixed costs are costs that don't change with the amount of production. So these are usually going to be capital costs, right? And probably the largest fixed cost for most companies is going to be real estate costs, right? So if you're a coffee shop, you're going to have to pay the amount of your rent regardless of how many customers you serve. And so that's a fixed cost from your perspective, okay? And then the other thing is opportunity costs are usually fixed costs as well, okay? Because what you would be doing with your time instead of running the business is going to probably be the same regardless of how many customers your business is serving. Okay. One thing that you should always keep in mind is that whether a cost is fixed or variable can sometimes depend on the time horizon, right? Meaning long run or short run. So for example, land and specific large pieces of equipment might be fixed in the short run, but in the long run they might be able to change. So going back to our coffee shop example, the amount of real estate that the coffee shop has to pay rent for is definitely fixed in the short run. But in the long run, if the coffee shop really wants to grow and expand, then it might consider branching out and renting a second space. Okay, in that case, the real estate cost would be a variable cost in the time span that it would take to find another space in order to open a new branch. Okay, so whether something is fixed or variable depends somewhat on the time horizon. Okay, now let's do an example where we show the cost function for a typical kind of firm. And here on the table, I am showing you the relationship between quantity produced and variable cost and fixed cost for a firm. So let's fill in the table. But instead of filling it in by hand, let's actually do it on an Excel spreadsheet because it'll be faster and more interesting. All right, so here's our Excel spreadsheet. I've preloaded it with the data from the table. And what we want to do is we want to calculate total cost, marginal cost, average total cost, and average variable cost. And here on the right, I've actually preloaded a graph that's going to automatically start graphing the marginal cost, the average total cost, and the average variable cost as we fill in those numbers. Okay, and you're going to see what it looks like. Okay, so let's start with total cost. Total cost is simply variable cost plus fixed cost. So that is going to be B2 plus C2. Okay, and then we're going to click and drag to fill in the rest of the column. All right, so how do we read this? Well, the total cost if we want to produce 1 unit is 100, and the total cost to produce 4 units is 160, and so on. Now let's do marginal cost. Okay, as a reminder, marginal cost is defined as the additional cost which is incurred by the last additional unit, which means that when the quantity produced is 1, the marginal cost is 100 minus 60, right? Because that's how much additional cost the first unit took. All right, and for the second unit, it's 130 minus 100. Okay, and so let's click and drag to fill in the rest of the table. And you can see right here, the graph has automatically filled in the marginal cost curve. Now let's do average total cost. Average total cost is simply the total cost divided by the quantity produced. So it's basically, on average, how much is it costing you to produce each unit. All right, so it's simply total cost divided by quantity, okay, D3 divided by A3. Let's fill it in. Okay, so average total cost is going to look like this. It's going to start out very high. It's going to go down, and then it's going to start curving back up again. And finally, let's do average variable cost, which is variable cost divided by quantity. So variable cost divided by quantity. Okay, so there's our average variable cost. Okay, and so this is what the cost curves for a typical firm is going to look like. And this Excel spreadsheet has also been uploaded to Canvas in case you want to play around with it. So the cost curves for a typical kind of firm are going to look something like this. All right, so let's draw our axis first. And when we draw cost curves, we're going to put quantity produced on the x-axis, and we're going to put cost in dollar terms on the y-axis. All right, and we're typically going to be drawing 3 curves. The marginal cost curve, which is going to look something like this. Average total cost curve, which is going to look something like this. And then average variable cost curve, which is going to look something like this. Okay, and so what I've drawn here is a fairly typical example of a cost curve for a typical firm, as we already saw with our earlier example. Okay, so now let's explore some of the properties of our cost curves. And if you'll notice, as I drew our typical cost curves, I always drew marginal cost such that it was declining to start with, and then it's increasing as quantity gets higher. And so the first thing we should ask is, well, why does marginal cost decline at first? Now, there are a couple of reasons why this is the case for the typical firm. And the first is that there are certain types of labor and capital that you need at least one of in order to run your firm, but you don't really need to buy another one until the firm gets very large. For example, every firm needs to do accounting, whether it's by purchasing a software or hiring an accountant. But you don't really need to hire more than one accountant or purchase more than one accounting software or upgrade to a better software until maybe your firm gets large. So the marginal cost for the first additional unit of production might be quite high because you have to hire that accountant or purchase that accounting software, but you don't really need to purchase another one until later. And so that marginal cost goes away after the first unit. The second reason marginal cost might be declining is something called learning and specialization, which is that when firms are small and initially starting out, they might not be very skilled, they might not be very efficient at what they're doing. As they start to produce more and more units, they start to realize how to do things better, they start to learn from their experiences and start to produce more efficiently. And so learning by doing could be another reason why marginal costs are declining at first. Okay, and then a third reason could be bargaining power and bulk purchases. So when you are very small and you have to buy inputs in small quantities, you don't have a lot of negotiation power with your suppliers. But as you get bigger and you start to purchase things in larger bulk, then maybe you have some more negotiation power with your suppliers, and your suppliers may give you some bulk or quantity discounts on your purchases. Okay, so for any of these reasons, marginal cost might be declining at small scales. Okay, so that's why marginal cost might be declining at first for small firms. But why does marginal costs increase as the firm gets larger and larger? So one reason could be that as you want to scale up your production beyond a certain point, you're going to need to spend money on a large capital investment. So think about a coffee shop that wants to expand beyond its original shop. At some point, the number of customers it can serve is maxed out because the shop is only so large. And the only way for it to serve more customers is to expand by opening another branch or moving into a larger space. But either way, that's very expensive, and so marginal cost is increasing as the quantity of production gets larger and larger. A second reason could be organizational complexity. So as a firm gets larger, it might require more resources just to manage all of the moving parts. So whereas when the firm started, it was just the founder and a couple of employees. There was no need for any middle managers. As the firm gets larger and larger, you start needing to hire employees whose sole function is to manage other employees. Okay, so organizational complexity could be another reason why marginal costs are increasing as the firm gets larger. Now let me talk about a concept known as economies of scale. Along with knowing the different types of costs, if there's anything else that I would want you to remember from this course, it's the meaning of economies of scale. A firm is said to have economies of scale if it's on the downward sloping part of its average total cost curve. All right, so the downward sloping part of its average total cost curve. If a firm has economies of scale, then that means that as it gets larger, it actually gets more and more efficient. Its average costs go down. Now, investors are very attracted to firms that have economies of scale because these are the firms that are going to get more and more profitable as they get larger. Moreover, as these firms get larger, it becomes harder for other smaller firms to compete on things like price because the larger firm actually becomes the lowest cost provider. And so think about how difficult it is for companies to compete with the likes of Amazon, which is able to offer one-day shipping at extremely low cost to the consumer and at a cost that probably no other company would be able to match. The opposite of economies of scale is diseconomies of scale. A firm is said to have diseconomies of scale if it's on the upward sloping part of its average total cost curve. Okay, upward sloping part. If a firm has diseconomies of scale, then that means as it gets larger, it also becomes less efficient. Firms with diseconomies of scale are going to be less attractive to investors because any gains in revenue from them growing larger are going to be offset by increases in average costs. And so it's also harder for firms with diseconomies of scale to achieve dominant market share in their industry because as it gets larger and more inefficient, smaller and more nimble firms are going to be able to compete more effectively with them on price. Okay, so when a firm is producing at its lowest possible average total cost, so the minimum average total cost right here, it's said to be producing at efficient scale. Now, efficient scale means that the firm is producing at the lowest possible cost per unit. And ideally, all firms would be producing at their efficient scale so as to minimize society's cost of production per unit. One thing to note about the efficient scale is that it always occurs at the point where marginal cost intersects the average total cost curve. Okay? And this happens because whenever marginal cost is higher than average total cost is going to be increasing. And whenever marginal cost is lower than average total cost is going to be decreasing. You can understand that by thinking about points per game in basketball. So if you think about the points that a player scored in his last game, if it's higher than his points per game, then points per game is going to go up, right? On the other hand, if the player's points from his last game is lower than his points per game, then points per game is going to go down. And so in this analogy, points from the last game is the marginal cost, right? Marginal cost is the cost from the last unit produced. And points per game is the average total cost. Okay, and so ATC is going to be going down whenever MC is below it, and it's going to be going up whenever MC is above it. And so the minimum point is going to have to be exactly where MC and ATC are equal to each other. Okay. All right, so far the cost curves that we've been looking at have been textbook examples of what you might call a typical firm, if by typical we mean a typical manufacturing firm. And it's true that for a typical manufacturing firm, costs are going to start by going down, and then they're going to go up as the firm gets larger, because to expand beyond a certain point in manufacturing, you're going to need bigger factories and you're going to need more factories. But today, manufacturing is becoming a smaller and smaller share of the US economy, and replacing manufacturing are intellectual and cultural products like software and entertainment. So I think it's worth our time to think about what a typical cost curve might look like for a modern software or entertainment company. Now, the unique feature of software and also of entertainment and media is that it's very expensive to develop, so it has a very high fixed cost. But once it's been developed, the marginal cost of producing and distributing it is basically very close to zero, right? So think about it. Once you've built your software or created your TV show, the only real cost to reproduce and distribute it is going to be the data bandwidth that it takes to deliver it to the consumer. And so software and media companies can be said to exhibit extreme economies of scale. And what that means is their average total cost curve is basically declining everywhere. Okay, even when the firm gets very large. And so when an industry has these extreme economies of scale, there's almost no limit to how large the firm can get. And so the downside of that is that the market might be more prone to monopolization. meaning the control by one single dominant firm. Right? Think about how true that is for the software industry, with Google being pretty much the one dominant player in the search and ad space, Facebook being the dominant player in social networking, and Netflix being the dominant player in streaming. And we'll talk a little bit more about monopolies in a later lecture. All right, so that's it for today's lecture. Like I said, this is my first time trying online video streaming, so hopefully it works out okay, and hopefully I can get better at this as we go along. You have homework from problem set 4, which is due Monday after spring break, and I look forward to posting new videos. And like I said, stay safe, stay healthy.